Hi everyone, it's Judy. Welcome back to the OnTrack podcast. Today we're having our first ever OnTrack Field Trip. We're on site at Michigan Tech, where today's podcast guest is Dr. Chris Middlebrook, and he teaches a class here on printed circuit fabrication. So we were able to sit down in his lab where they actually make circuit boards here right on campus. So we're going to talk about his students, the program, and all the amazing work here they're doing to prepare EEs for the real world. So lean in, enjoy. I'll see you on the other side. Welcome to Altium's OnTrack podcast, where we talk to leaders about PCB design, tackling subjects ranging from schematic capture all the way to the manufacturing floor. I'm your host, Judy Warner. Please listen in every week and subscribe on iTunes, Stitcher, and all your favorite podcast apps. And be sure to check out the show notes at altium.com/podcast, where you can find great resources and multiple ways to connect with us on social media. Chris, thank you again for inviting us here to MTU. It was a delight to meet your students today.
Well, it's great to have you, and really appreciate the support that Altium's been able to provide.
Yeah, it's our pleasure. So, can you tell us a little bit about your personal and professional background and and tell us a little bit about MTU?
Sure. I've been a professor here since 2007 at Michigan Tech. We've had a research project previously, a number of years back, that was involved in high-speed interconnects within printed circuit board shops, where we got involved with Calumet Electronics just north of here. And so that kind of set the stage for some of this sort of work here. Michigan Tech is a smaller engineering-focused university, but we do pride ourselves in the hands-on kind of approach, and engineers that are well-versed within practical design and implementation, as well as theoretical type work.
Well, we love that at Altium because we really see, as we're out among students and university, a big need for that hands-on, particularly because there's really a shortage of talent in our industry, whether it's design or technicians in a board shop or assembly shop. Can you tell us a little bit, and I know that's something you know about and something that's near and dear to your heart, could you tell me a little bit about what you're hearing in regards to the shortage of talent in the industry and what specifically you're doing to address that?
So you hear about these ebb and flows within sectors within the educational area. We used to have, a high-level kind of expertise within circuit design and layout and stuff like that, and that kind of faded away a little bit, but now you see this resurgence in manufacturing across all sectors that are trying to tap into this kind of talent field of engineers. And as a university, we want to rise to that challenge and basically equip our students with the necessary skill sets that they're going to need to drive the next generation of technology out there.
Well, I can't tell you what it means to me as a person who has been probably 25 or so years in printed circuit board fabrication assembly to actually present to a class called Printed Circuit Fabrication, a class at a university. So that's really great. And
as you see, we're in the lab here. This is where one of the labs that the students are using, where they're actually making printed circuit boards.
So tell us a little bit about this room and where this equipment came from, or what specifically they're doing in this room.
So we have a number of rooms, and that's one of our, building a program, you've got to find lab space if you want to do hands-on type of things. And so we've had to kind of stitch things together to a certain extent. So we have different laboratories that we're using across campus. This is my prototyping research laboratory, but we have fume hoods that are able to handle the chemical processing, the wet chemical processing that the students need to use. So they do some of the board etching and development stages within this room here. And anything that's sensitive to photoresist, the white light and things like that. We have other labs that are in different locations. Trying to bring all that together would be a really nice piece of that, but we're making it work with what we can. And the students are in here and working in small groups, and they rotate around the lab. So we've been able to handle it.
So have you also, you mentioned Calumet, which is very close here to the university,
yes.
And have you been able to tap into, say, taking the students inside of a professional shop and exposing that?
Yeah, Calumet's been fantastic. They're we might have been able to run the course, but there's no way we'd have been able to do it in the time frame that we were doing without their expertise and help. They've not only provided their engineers and scientists and technicians to help us get things up and running where we have problems, they've also supplied a lot of raw materials for us and things that we've needed for the class. But as you mentioned, the lab tour, so what we purposely designed the lab tour to come at the end of the class in terms of the facility tour up at Calumet, so the students were already versed in the fabrication processes and already understood that, so they weren't going up to a new plant and then seeing all these processes they were not familiar with. They were already familiar with wet chemical processing, etching, developing photoresist and solder masks and things like that. So then bringing that in at the end of the class for the tour was really great. They got to see it on a much larger production scale and a much more automated and how better their boards look than the students. But
so how did they respond to being in that professional environment with drills and full-size plating facilities?
Yeah, they loved it. I mean, all the responses I've heard from the tours are great. Nobody, when we were talking about scheduling the tour and trying to figure that out, everybody wants to be part of it because they love that. They wanted to see, they've been doing it now, and they were really eager to see that kind of knowledge on what it's really like in a real board shop. So.
Mm-hmm. So overall, having this hands-on experience, getting to see a shop like Calumet, and these are all EE students largely that you're
yeah, we have
with?
a couple computer engineering, but the department is electrical and computer engineering, so you see students across those two spectrums. The course is meant as a introductory kind of course, not that we have seniors that you've met before, and juniors primarily in the class as the first offering. You don't get to necessarily pick and choose who takes the class. We opened it up, and I was hoping to get to advertise this to the chemical engineers and material scientists, but it filled up with EEs right from the get-go. I didn't have to do any marketing or advertising with the class at all; it just all filled up. So we get. Even the CP, the computer engineering students, realize the value here because we're talking about all these kind of areas blending together in different designs or firmware or products and stuff like that. So,
do you see that as EEs that really the light bulb's going on for them as they really get their hands on some of these chemicals? And
I think so. The part of the class, like I mentioned, was an introductory class to get them excited about electronic design, manufacturing, that area. But they can come into this without having circuits, without having electronics, without having a lot of that. So they can kind of get a taste of this, and I'm seeing that even in the students, they're really craving more, especially on the design or the population of the boards or all the other aspects of that. And so they've really gotten their hands on it, and it's interesting because of the feedback that I get. I actually am running one of the lab sections with my TAs, and so you hear comments back from the students of, this is great, I'm actually doing something with my hands, I'm actually working with this, and it's quite different from the normal type lab sections where you give them a lab, set them down on a lab bench, and just let them work it out by themselves.
Right.
You're leading them through there. You've got to have the procedures in place and the supervision, everything with the chemical sets, but it's an introduction. They understand what safety data sheets are now and things of that nature. So it's been good exposure, and they realize that maybe that's not going to be their career forever, but they should have a taste of that and understand what goes on behind the scenes or in a board shop. So if they're working in those overlapping areas, they have a better technical skill there.
Why do you think there's sort of this disconnect on hands-on experience sort of pervasively in universities, and how do we get this message out that it's really valuable?
What is some of it, there's a lot of reasons, I guess, and one of them is cost, right? I mean, these things take cost to do. We've got materials and chemical sets and things of that nature. We've been very fortunate in the support we've received from the community in terms of donation of materials or chemicals and things like that. So we haven't, while we've had to spend some money on the lab stuff, we haven't had to bear the full burden of that. So that's been really nice. So there's the cost aspect, but then from the student culture changing, you're not seeing a lot of students that are tinkering with things that you might have seen way back in the day, but it's changing, right? So you go and grab different components and you put those together and you integrate them into a system and program them or whatever you're doing. And so you're seeing that kind of different mindset coming into the university. But we can address that by offering courses like this where the students get in, they get their hands dirty, they're actually making things. And we had a midterm report presentations that all the students had to do, and they'll be doing a final one here next week. But it was really neat to see the pride and joy that they had in putting these presentations together, what went right, what went wrong with their processing, and it was really nice to see that. And they were very happy about it. They were smiling, they were making jokes. So I can say pretty certain that they've enjoyed the class overall. So it's been good. And trying to address those challenges is part of the university's role and what we should be doing for our students. Yeah,
it's really truly music to my ears, and this is why I wanted to have you on the podcast today. I hope we can inspire other universities to follow your lead here. So obviously having Calumet clear by and be such a wonderful support for you has been very valuable. If you could wave a magic wand, what else can we do as industry to support your program? And what are things are on your wish list? What more would you like?
So some of the things, university obviously they want better talent, they want better students coming in to start on that process to hit the road running right away. And so one of the things that we can work on, and we're trying to do, right, when we start talking to companies about lab sponsorship. I mentioned the fact that we have several labs that are separated. One concise facility would be really nice where we could bring everything together, make that a showpiece. In this lab, as you look around, you don't see any windows to the outside world. So we're missing a large population of potential students or visitors or anybody coming through there that's seeing that this work is going on. So there's a lot of different areas that students can go into, and you don't need to force them into one area or the other, but you should definitely expose them to some of that. And so having a larger space that supported this kind of infrastructure that made things more centralized and localized and gave visibility to tours, and the parents that are coming through thinking about kids that are coming to school here and that sort of thing. And the companies can get the brand recognition, they can, and beyond that, then the next level there is more interaction. So companies sponsoring projects and being mentors to these students, and because the students really respond to that very well. Whenever they see somebody with a real product that's working at a real company, they love that interaction. The faculty members can teach them the theoretical stuff and things like that, but when they really get down into the real life things that's going on, they want to talk to the engineers that they're making their livelihood out of that thing.
Right.
And so being a faculty member and an advisor for some of these teams and seeing that interaction, that's really when the students really perk up, is when you have a really good mentor that's helping, guiding along the way. So we look for opportunities to broaden that sort of thing out within the electronics design, manufacturing kind of field.
So the talk that I did today was to sort of help students think about the skill sets they need to onboard as potential future design engineers. So that's part of what you call a guest lecture series. Can you touch on that a little bit and tell us about your series? And
this has been one thing that's quite different from most classes. The course itself is heavily into the lab, right? The students are building projects, but there's also the lecture component of that. And me, rather than me trying to cover the various aspects of everything, it was a much better application to go out and look at industry resources and try to bring that talent in. And as I mentioned before, the mentorship and the interaction with industry is what really piques students' interest. So why not bring some of those talent into the classroom and have them give their briefings on various topic sectors, and the students are exposed to a wide area of different technologies, engineering disciplines, and team environments and things like that, and really trying to broaden their experience. They've got the core piece of their educational knowledge, but how do they cross that across the whole spectrum, of different type talents? And that's been really great. The lecture series filled up. We didn't have really any days once we got going that was open for class. So But the students, like I mentioned, the midterm reports, we actually did that on a day they normally wouldn't have class, which is kind of uncommon for students to want to do that. But they wanted to do that and they were willing to do that. But we had to do that outside of the lecture series because we had such great lecturers lined up, including yourself, to do this.
So can you give us just a smattering of the topics you've covered during this series?
So they've ranged anywhere from electroplating within the printed circuit boards to solder mask to assembly to Happy Holden was in and gave some talks on future of this kind of industry and where that's going. We didn't pick in terms of straight linear kind of progression in fabrication, but just whatever worked with the lecturers' schedules and things like that. So they got to see all these pieces. So if they saw some of the pressing issues, how you do a multi-layer press within a couple weeks of when they did that in the lab, that was great. But even if they saw that later, they might have already had experience with that in the lab, so it resonated as well too. So we had just a smattering of all kinds of different topics, which from a student's perspective, can be a little daunting and maybe scary at first because they, to a certain extent, they want that kind of structuredness. But with the generation now, they're a little bit more adaptable and like that kind of thing and can move with the flow a lot. They're used to turning things, 90 degrees and going in a different direction.
On that topic, you and I were talking a little earlier about millennials who tend to, seems like in the press or online, sort of take a lot of hits. They get written about being lazy or, whatever, not nice things generally. I haven't found that particularly to be true. I mean, I am mostly meeting with the university students, but you mentioned that the students are coming in even when it's not a day they're required to be in class, but they're hungry for that. So can you talk about sort of some positive things you see, elements of sort of the millennial culture?
Sure, I'd be glad to. What I see in terms of the students, and there's a wide varying, cross section of student population, but overall in general, they're very knowledgeable and they have all this information ahead of time. So we're seeing a lot more students come into the program, into a program like electrical and computer engineering, already knowing where they want to be and what they want to do, right? Whereas normally, maybe back in the day, they knew they wanted to be electrical engineers, and then they kind of figured out where they wanted to be. But even before that, with some of the things with FIRST robotics that are going on and things of that nature, students are already gravitating towards that. So you've moved that bar down a lot lower. So they're already quite well, they've been programming, they've been doing a lot of things before they even hit the university floor. And so trying to, capture that and steer that drive and thirst for that is one of the challenges we have today to try to rise to their kind of expectations of what they want to see in a university experience and how we can provide that to them, as well as keeping in mind what the employers, that potentially are going to hire these students for their careers are looking for.
You had mentioned that you were an engineer at Crane for a while. Do you think that having that time sort of in industry and your exposure has really sort of informed the things you wanted to do here?
I try to work things in. I like the fab type side of things. I like making things and devices and seeing real things work, and hopefully these products make it into something that goes out there and is a great success. Or you have a student that maybe you mentored or developed and went out there and did that. Having an industrial kind of background, I think, is nice because I know what's going on in terms of applications, in terms of how they relate back to a real life product, right? Because you could be in a lab and be working on something for the next 20 years, but if it never makes it out of that lab, it does nobody any good, right? So at some point, it's either got to be adapted by somebody who's going to bring that to a product, or somebody is going to use that in another way or form or shape. So that's where I like to work in the exciting kind of stuff, and that's what gets me out of bed in the morning.
Right. Well, again, so much a fan of MTU, and thank you so much for allowing us to come here today.
Well, thank you.
And thank you for all you're doing here. I hope this podcast will inspire other universities and other industry professionals to think about sponsoring or mentoring their local universities and and doing more programs like this.
If anybody wants to reach out to me, I'm more than willing to share what we've done here and collaborate or whatever needs to be done to help people out, because we've gone down the road a little bit, so might as well not reinvent the wheel.
Yeah, that's for sure. Well, we will definitely share links to Michigan Tech University, and also we shot a video of my talk here today and also some conversations with students. So we'll make sure that we share those links with you, and we'll put those on our academic website. We do now have a formal academic website that's live. We'll share that link with you, and we hope that you'll dig in and be inspired by all the work of students and universities like MTU. Again, Chris, thanks so much for joining us. Thanks for joining us on today's OnTrack podcast. We look forward to hanging out with you next time. Until then, remember to always stay on track.